All right, welcome to Foundations 30. This is lesson 2, Introduction to Odds. So odds and probability are related to one another. Oftentimes we talk about odds like when we're gambling or things like that, like your chances of winning are 4 to 1 or something like that. So what odds are? We can have odds in favor of an event or odds against, okay? So the odds in favor mean the ratio of the probability that an event will occur to the probability that the event will not occur. Okay, so it's the probability of A to the probability of not A. Now, if you think about a probability type question or what that might look like is we know that I might have like say 2/5 might be the probability that something will happen. The probability that it won't happen then would be 3/5 because they have to add up to 1. And then think of this kind of like a fraction. What I could do is multiply by 5 on both sides, and this comes out to be 2 to 3. Okay, so since that is the case, we could also have a formula that says the number of favorable outcomes for A to the number of favorable outcomes for not A. Okay, so depending on the question, we can either use probability or number, more often the second of the two. The odds against is the ratio of the probability that the event will not happen to the probability that it will happen. Okay? And remember that we need to express odds in whole numbers, and if necessary, we reduce them like fractions. Okay? So if you had like 4 to 6, you need to reduce that to 2 to 3. Let's look at an example. So a TV station is hosting a contest. Alice, a participant, can choose one of 7 doors to open, and she's going to win whatever prize is behind the door. And behind 7 of the doors, these are the prizes. Okay, so one of the doors offers a trip. 2 of them contain gift certificates. 3 contain restaurant dinners. And 1 has no door prize at all. Okay, so what are the odds in favor? Okay, odds in favor of choosing a door with no prize. So when we do that, what we want to do then is basically say how many doors, the number that have no prize, because that's what it's asking me to find, right? The odds in favor of that, to the number that do not have no prize. So in other words, everything else, right? So the number that have no prize is 1. And then the number that are not that, which would be everything else, would be 6. Okay. What is the probability of choosing a door with no prize? We've already done this. So the probability of getting no prize. Remember, it is the number of favorable, which would be 1, out of the total number, which is 7. Now, what I want to point out is that the denominator of my probability is equal to the sum of the odds. Okay, so lots of times the most common mistake is students might make this and say 1 to 7, okay, because that's the total number, but it is the number in favor, the number imposed. Okay, what are the odds of Alice winning a gift certificate? Okay, so then I want to know basically how many doors have a gift certificate and how many doors do not have a gift certificate. Okay, so the number that contain a gift certificate is 2. The number that do not contain a gift certificate is everything else out of these 7, so 5. So my odds are 2 to 5 that I will win a gift certificate. Okay. Example number 2 says a tire manufacturing company does a random test of tires coming off the product line to ensure that they are being produced correctly. After testing, the quality control manager calculates the experimental probability of a tire having a defect is 0.0003. So it's giving you it as a probability. So we're going to have to use that first formula, not the second. Okay, so what are the odds in favor of the tire being defective? So I want the probability that it is defective as a ratio to the probability that it is not defective. Okay, or we could have said defective with a line over top. So the probability that's defective, that's given in the question, is 0.0003. And remember that the negative, that everything else would be not defective. So 1 subtract 0.0003 will give me my not defective. So this is going to be 0.9997. And remember that we need to give these as whole numbers. So basically, if I multiply this by 10,000 in each case, this will give me 3 to 99.97. Okay, so what this says is that basically I would have a total of 10,000 tires. 3 of them will be defective, 9,997 will not. Okay, so there is my odds in favor. The odds against it being defective, right? So then that would be, I want the probability that it's not defective to the probability that it is defective. So essentially the exact opposite of what I've got up in A. So this will be 99.97 to 3. In a production line of 30,000 tires, how many tires would you expect to be defective? Okay, well, if we understand what the odds means, this means that out of 10,000 total, because I have 3 that are defective, 9,997 that are not. So out of 10,000 that are defective, or 10,000 tires in total, I have 3 that are defective. So I'm asking you how many out of 30,000 would be defective. Okay, so you can either cross multiply if you want, or you can probably just logically think of that. If there's 3 in 10,000, there would be 9 defective in 30,000. Okay, and then not defective, well, that would need to be all of the rest of them. So out of 30,000, 9 are defective. That means that 29,991 are not defective. Okay, let's look at some card questions and then you can practice them on your own. So determine the odds in favor of drawing a face card from a standard deck of 52 cards. So the odds in favor of drawing a face card. Okay, so that means that I want the number of faces to the number that are not faces. So in a standard deck of cards, there are 12 face cards. There are 52 cards altogether. 12 of them are faces. That leaves that there are 40 that are not face cards. And when I reduce that, that comes to 3 to 10. Okay, determine the odds in favor of drawing a red card. So again, then I would want the number that are red to the number that are not red. So the red cards, there's 26, not red, would be the rest of them. So 26, this is 1 to 1. And the odds against drawing a black card, so that means I want the number that are not black cards because it's odds against to the number that are black cards. So again, this would be 26, sorry, not equals to, it's a ratio, 26 to 26, which is 1 to 1. Okay, that's our quick little introduction to odds. So I want you to go ahead and practice some questions on your own.